In Lesson 5.3, we'll be looking at the example, how do we inherit blood type, and we'll be using the binomial probability formula. In this problem, genetics says that the genes children receive from their parents are independent from one child to another. Each child of a particular set of parents has a probability of 0.25 of having type O blood. Suppose these parents have 5 children. Find the probability that exactly 3 of the children will have type O blood. So when reading this, I first see that we're told that the genes from one child to another are independent. I know that I have 5 children being born, and I know the probability of type O blood is 0.25. So this tells me that we are looking at a random variable x, where x represents the number of children with type O blood, and that this is a binomial random variable. We have n equals 5, p equals 0.25, and what we're asked to find is the probability that exactly 3 have type O blood. So from the reading, you can use the formula. The probability of x equaling a specific value, in our case 3, is using n choose k, p to the k, 1 minus p to the n minus k. Now that we've evaluated our n and our p, our k is then going to be the exactly 3. So plugging into this formula, it's going to look something like this. And what we need to then first evaluate is this combination here. So you've learned a couple ways to do this in Chapter 4. I'm going to, from the reading, use this formula here. So 5 choose 3, I have 5 factorial over 3 factorial, 5 minus 3 giving me that 2 factorial, for a total of 10 different combinations. So completing the formula now with the actual multiplication, I have 10 times 0.25 raised to the third, 0.75 squared, and that gives me a final probability of 0.0879. And that represents that the probability of, in these 5 children, exactly 3 of them will have type O blood. If you'd like more practice with the binomial probabilities, please try exercise 5.